Hello, everyone. It is 2:15. We'll wait a few more moments and then we will get started. While we wait, this is RESNA Wheelchair Transportation Safety Standards. If this is not the session that you signed up for, you can leave at this time. Otherwise, we'll get started in about a moment. Welcome, everyone. This is RESNA Wheelchair Transportation Safety Standards. Miriam will be your presenter. Please remember to keep yourself on mute and direct any questions to the chat. We look forward to hearing from Miriam, and without it, please take it away.
Hi, everybody. My name is Miriam Manary, and I work at the University of Michigan Transportation Research Institute. And I'm here to talk about RESNA Volume 4 standards that have to do with wheelchairs and transportation. And I'd like to acknowledge my co-author, Nichole Orton. She is not here today to present, but just this morning, she helped me work through the whole presentation and made some important improvements. So you're definitely hearing from both of us. The Volume 4 safety standards deal with a situation that we call wheelchair transportation safety. But I want to clarify that what the situation we're talking about is when people use their wheelchairs as a motor vehicle seat. So this is someone who doesn't transfer to conventional vehicle seating, but instead stays seated in their wheelchair for the whole ride. And when developing these standards, we leaned heavily on the precedents and the principles of conventional automotive safety standards. So we looked to the federal motor vehicle safety standards to try to figure out what were the general principles and how can we adapt those to the situation where a person is seated in their wheelchair. So I want to start off by just listing the handful of fundamental principles. So hopefully you can see how they come through in the standards. But one of the main ideas is that when we look at motor vehicle crashes as a whole and the injuries and the fatalities that happen as a result of them, the majority of these injuries and fatalities are a result of the occupant contacting something. So either they're contacting the vehicle interior or they've been ejected out of the vehicle and they're contacting an unfriendly surface outside the vehicle, like a tree or the ground. And so if we can keep people from hitting other objects in the vehicle, we're winning a big part of the game. A second cause of serious injuries is misused or non-used seatbelts. So obviously non-used seatbelts leads back into the first one where you're at risk of hitting things. But if you're not positioning the seatbelt appropriately, so it's loading parts of your body that can take that high restraint force load, this can also be a cause of injury. So we're all about minimizing the human collision, and it's not a super sort of sexy idea, but the most effective occupant protection system for automobiles is the seatbelt. So a seatbelt, you can see pictures here of people properly wearing their seatbelt or kids in child safety seats. But this is the sort of protection that really is the best that we have to offer right now. And certainly the level of protection we want to offer all of the occupants of the vehicle. This is just a little video that shows the importance of minimizing collision. So it's a sort of a simple comparison of these little toy cars. One of them will have an egg wearing a seatbelt and the other has an egg not wearing a seatbelt, and you'll see just that simple little strap keeps the egg from contacting the unfriendly structure and keeps them intact. So sort of a visual to go with that idea of you don't want to hit other things in the vehicle. So that being said, the first choice for people who are in the wheelchairs is to transfer to conventional vehicle seating or a child safety seat and use the occupant restraint system offered by the vehicle. But we know that for some wheelchair users, it's just not feasible to transfer, or it's unsafe, or it puts them in a situation where their medical needs can't be met. So for people who are going to stay in the wheelchair, all of a sudden we want that wheelchair to have a lot of characteristics of a vehicle seat. We want it securely anchored to the floor. We want it not to interfere with our lap and shoulder belt fit. And we also, so all of a sudden we're asking the wheelchair to do a whole nother set of functions beyond all the great functions that it already does. So both of these goals of having a well-secured wheelchair and having a good fit of the occupant protection system are much easier to achieve if you have a wheelchair that has been designed for this purpose. So there's 5 basic principles. One is that we want to secure the seat, in this case, the wheelchair, independent of the occupant. So we don't want the wheelchair to load the occupant and increase crash loading. We want to orient wheelchairs facing forward in the vehicle, especially in small vehicles. I will talk about the one exception. It used to be very common for people to line or load wheelchairs sideways. That is, none of our crash testing and the way that we know how to protect people is not coherent with having people ride side facing. Here's a video of a crash test of a side-facing wheelchair. So generally frontal impact sees the highest load. So if you're orienting the wheelchair laterally to that frontal impact, you usually do not see the best strength out of the wheelchair. I'll play this again. You can see there's a flash of light when the impact starts to happen. And particularly because many wheelchairs are designed to fold along the center line, orienting side-facing can be dangerous. Another option would be orienting wheelchairs rear-facing. And this, we know that very small children under the age of 2 are best protected riding rear-facing in their child safety seats. So some people have extrapolated that and tried having people ride rear-facing in small vehicles like minivans. And the wheelchairs were just never meant to be loaded in this direction. So I'll show you what that crash loading looks like. You'll see that when the crash initiates, all of the primary restraint of the occupant, those loads go into the seat back, and it just was never intended to serve this purpose. So hopefully those emphasize the idea that you should be forward facing in your wheelchair in small vehicles. And then the 3 other things are just properly positioning the webbing based belt, so the seat belt. We want the seat belt to restrain or protect the upper body and the lower body. Ideal positioning for the shoulder belt would cross the center of the shoulder, the sternum, and then attach to the lap belt over by the hip. We want the lap belt to be low, touching the pelvic bone and touching the top of the thighs, so that we are applying the restraining forces to skeletal regions of the body that can handle that high load. You never want to have the lap belt up on the soft abdomen where there can be a lot more risk of injury. And the last one is that when you are anchoring lap belts, you want to make sure you can get a relatively steep angle. So this angle I'm talking about is a side view angle. And we want to see it ideally between 45 to 75 degrees relative to vertical. So RESNA, this brings us to RESNA Volume 4. There is an absence of government legislation in this area, and that's because the US Department of Transportation has decided that they are not going to address the situation where somebody's using their wheelchair as a motor vehicle seat in the federal motor vehicle safety standards. So as an alternative to that, RESNA developed these voluntary standards that represent sort of the best practices associated with these pieces of hardware. And there's 4 standards, and they're grouped in relative to what we're testing. So the very first one that we developed was WC18, and that's wheelchair tie downs and occupant restraint systems. So those are the hardware that secures the wheelchair to the vehicle and provides the lap and shoulder belt, usually, that protects the occupant. WC19 is about complete wheelchairs that are used as seats in motor vehicles. So this has to do with the wheelchair itself, how it responds to load, and the features that it has to make it compatible with motor vehicle travel. WC20 is a standard for wheelchair seating, specialized seating that comes from a third party. So someone who makes seating but does not make the frame that it goes on, seating that can go on a variety of frames. That's the focus of WC20. And then WC10, which is an outlier in many ways, it addresses wheelchair spaces in large accessible transit vehicles. So these are large vehicles that travel fixed routes, have trained drivers, allow passengers to stand if they wish inside them. And so it's a whole different crash risk environment. And I'll go into the details of that. But so the first 3 have to do with passenger vehicles, and then the WC10 has to do with large accessible transit vehicles. I wanted to point out that each of these RESNA standards has an ISO mirror standard, just to make you aware. So for WC18, the mirror standard is ISO 10542-1. This was last revised in 2012, but a new revision is starting this year, 2022. So that means, given a 3-year cycle, you'll probably see a new version of that in 2025. WC19, our standard of wheelchairs, its ISO mirror standard is 7176 Part 19. The official last revision date is 2008, although a new version is just coming through the very last set of balloting. So the next time I give this presentation, I'm hoping I can put 2022 after Part 19. Wheelchair seating systems, that was WC20 in the RESNA universe, is the ISO mirror standard is 16840-4. And then rear-facing wheelchair passenger stations on large accessible transit vehicles, WC10, its mirror standard is ISO 10865-1. These sets of standards are similar in intent, they're similar in content, they aren't exactly the same. So there are some important differences. And as I go through this, I'll call out some of the ones that are most salient. I made a designation about this sort of severe impact load environment, and we made a symbol to designate crash tested hardware. So this is WTORS wheelchairs and aftermarket seating that meet WC18, WC19, and WC20. So those 3 standards are for products that can be used in smaller passenger vehicles like minivans that have to be crashworthy under high impact loads or high G loads or severe impact loads. So this is hopefully a symbol that we can start to associate with those that passenger car environment. All right, so I'm going to start with WC18. WC18 is a standard that deals with wheelchair tie downs and occupant restraint systems. And what does the standard require? Well, the WTORS that meets WC18 must have independent securement of the wheelchair. So the wheelchair is not secured through the, or by loading the occupant. It has to provide both upper and lower protection, lower torso and upper body protection to keep people from hitting their heads, from having those adverse contacts. And it has to be crash tested, and we're using a crash test protocol that is similar to the one that we use for testing child safety seats. So it's a delta V of 30 miles per hour and a 20 G environment that can be up to 26 Gs in the peak. And a lot of people are concerned about this 30 miles an hour number, just because when you think of speed limits. It sounds like a low number, but this is the change in velocity that happens over 80 seconds. So you're going from 30 miles an hour to 0. And actually, when we look at all the crashes that happen in the United States, this delta V, a delta V of 30 miles an hour, is more severe than 96% of towaway crashes. So if you take all the crashes, presumably the towaway crashes, meaning the crashes where the vehicles could not be driven away from the scene, are more severe than the fender bender type crashes. It really covers 96% or more of crashes in the United States. Right now we have several styles of WTORS that comply with WC19. This 4-point strap type is probably the most common. So it's called 4-point strap type because it's very descriptive. There's 4 straps that connect to 4 points on the wheelchair and 4 points, reinforced points on the floor. But there's also docking systems. This is one of the more common ones where there's a pin hanging down that's captured by a device on the floor. This sort of device is usually, is always actually intended for a private vehicle where they know exactly which wheelchair will be riding in that vehicle, and the wheelchair and the dock need to be specifically tuned to work together. So this is a sort of a bespoke solution or a tailored solution for a particular person riding in their own vehicle, and they can dock using this system that's been tuned to their wheelchair. If someone else with a different wheelchair gets on, they can't use the same docking system. Whereas the 4-point strap type tie down is very versatile. WC18 differs from its mirror standard in ISO 10542 in a few key ways. And probably the most important one is that you're required in WC18 to pass the test where in a situation where the lap belt is anchored to the surrogate wheelchair. And what this does is delivers higher loads to the rear tie downs. And so there's a higher strength requirement for the rear tie downs. There's also additional requirements for the reconfigurability of the shoulder lap belt so that we can have more options for routing it effectively around wheelchair features, so that we can make sure that we get that great fit of the lap belt low on the pelvis touching the top of the thigh and the shoulder belt coming from the shoulder across the sternum to the opposite hip. I did also want to mention there is another standard from the Society of Automotive Engineers called J2249, and this is an older version of WC18. And when we improved on 2249 and we made WC18, we just figured everyone would be on the bandwagon and they'd all just start using WC18. But what is really happening is that people see that there's 2 US-based WTOR standards, and it causes a lot of confusion. Which one should they be complying with? So just in the past 6 months, RESNA and the Society of Automotive Engineers have agreed to make a collaborative effort, and we're going to revise WC18 and make it a single harmonized standard that exists in both the SAE world and the RESNA world, hopefully to reduce confusion and make sure that all of our products are meeting the same level of safety. I wanted to talk a little bit, this will be another reoccurring theme, but having a seatbelt system that can that has more reconfigurability and more disconnecting and reconnecting parts can really help with routing the belt to the pelvis. So this is a picture that shows you one particular situation where there isn't really a great way to route the belt. You can go on the outside and through the whole of the of this armrest, but then you might be displacing the shoulder belt. You could go over the top of the armrest, but then you might be routing the belt too high. So having these requirements for disconnecting parts that can be reconfigured means that we can have a pelvic belt that goes correctly on the pelvis and then goes through the gap between the seat back and the cushion to get optimal fit. So that's one of the differences between WC18 and ISO. A system like this can meet ISO, but ISO does not require all those different levels of reconfigurability. All right, so that's all I have on WC18. So I'm going to move on to WC19. WC19 is our standard for wheelchairs, that are used as seats in motor vehicles. So someone is sitting in the wheelchair, and all of a sudden this wheelchair that's designed to roll and fold and meet all these other needs is now supposed to be that very stable, secure seating point in a vehicle. So in order to meet the standard, the wheelchair has to have 4 easily accessible securement points so that it's compatible with strap type tie-down systems. It has to offer the option of, so it doesn't need to necessarily always be used with, but it has to at least offer the option of a wheelchair anchored lap belt. And later in this presentation, I'm going to go over why exactly are we trying to get people to consider a wheelchair anchored lap belt. Again, we're using a crashworthiness, a crash test, a frontal crash test. Frontal crashes are the most severe and also account for the highest numbers of injuries and fatalities right now in our current vehicle fleet. So we're testing for crashworthiness, again, using that 96th percentile crash event. A couple other things, we have so much trouble with seatbelt fit and seatbelt ease of fit and quality of fit that we also have some annexes that specifically address how easy is it to adjust and use a vehicle anchored seatbelt. And there's also a lateral tip test. So for these 5 things, well, actually for the first 4, don't think I have a picture of the lateral tip test. I just wanted to give you a glimpse into what a compliant wheelchair might look like. So this first one, 4 easily accessible securement points. They have a defined geometry, and this size and shape is meant to be able to accommodate a standard hook, or there are still some tie-down systems where you must bring webbing up from the floor and thread it through a portion of the frame. So this is also large enough so you can thread webbing, that seatbelt fabric, through it and clip down. It's also not so big that you have situations where the hook interface is going to easily disconnect. So we don't want to have that either. So there's usually 4 securement points, 2 on the front and 2 on the back. With very heavy wheelchairs, there's sometimes add 2 extra on the back. So there's 4 on the back and 2 on the front. They have to be easy to use from transportation providers. We've heard that they want it to be quick and easy. So you must be able to comply with the standard. You have to be able to hook to each of these securement points in 10 seconds or less. And I just wanted to, again, emphasize that idea of, 4-point strap type tie downs are emphasized in our standards. And that's because they're the most common type of wheelchair securement system that's used. And they're particularly effective in public transportation where one wheelchair station has to accommodate a wide range of wheelchair types, or a school bus that has to accommodate a wide range of wheelchair types. A 4-point strap type tie down, the same tie down can be used on many different wheelchairs. They also are just very effective at what they're trying to do. And they provide protection not only in the frontal crash that we test them to, but we see in the field that in side impact and rear impact crashes, this 4-point strap type, just because you have basically the 4 corners of the wheelchair tied down, they do a great job of securing it. I had another thing to say and it left, but maybe I'll think of it later. Another thing that WC19 requires is for the very smallest wheelchair occupants, so occupants 50 pounds and under, we require there to be, instead of focusing on a 3-point belt, these wheelchairs need to have an integrated Crashworthy 5-point harness. When we first started with the standards, we thought that kids under 50 pounds, they'll just transfer to seats, but child safety seats or booster seats, and we felt like we didn't really need to cover this segment. But what we really found is that kids were being prescribed and were using wheelchairs in this range of 15 to 22 kilograms, and that they weren't transferring, and we needed to have crashworthy options for them. So we developed the requirements for the 5-point harness and a long supportive back, basically drawing directly from the child safety seat standards, FMVSS 213, to make sure that we're affording these kids a similar level of safety as they would get if they were sitting in a child safety seat or car seat. As I mentioned before, one of the requirements with WC19 is that you have to provide the customer the option of a wheelchair anchored lap belt. And this is an example of what one looks like. The wheelchair comes down, it's anchoring to the rear securement point so that you can, because that's a strong point. It has a buckle in the center. And it also has this WC19 designated interface so that a shoulder belt coming down from the wall can connect with any WC19 compliant belt to create a complete lap and shoulder belt system. There's a lot of emphasis in 18 and 19 on a wheelchair anchored lap belt. And so I just wanted to go through why do we push this so hard? We haven't had great success necessarily in getting this to happen in the real world, but we think it's important to have it as an option. I wanted to go through some of those reasons. Well, first of all is we have all sorts of problems in the field with poor lap belt fit. So some situations, people are going in front of the armrests. You can see that this belt is nowhere near the pelvic area. It's not touching that bony surface. Issues with going over the armrest where the belt will cross high on the soft abdomen. Whereas if we have a tailored wheelchair anchored lap belt, we can get this perfect fit that we're looking for the lap belt. Another reason is that it can create a situation where you have less intrusion of your personal space by the transportation provider. So if you are getting on a bus and someone has to come back and help you with the 4-point tie down and applying the belt, most people are not comfortable with a stranger coming and routing a belt around their pelvis. It's it's your personal space and can make you uncomfortable. Also, if you're it makes the whole time to secure the wheelchair and get ready to go less, so it reduces that dwell time of the vehicle, and it helps again with getting that good fit, and hopefully reducing the dwell time means that there's less stigma for the wheelchair user if there's other people in the vehicle. Another reason why we are really excited about a wheelchair anchored lap belt is that we have a lot of pretty alarming data about misuse and non-use of seatbelts in the field. So first I want to talk about these two photos. These were some volunteers who came in and showed us they have their own customized vans that they drive from. And we had them come in and show us how they get in and out of the van, how they secure their wheelchair and how they use the seatbelt. And this person is taking the shoulder belt and they're looping it around the cane and then back, it's going down to the floor. But you can see this is the cane's not strong enough for this application. We have the belt crossing, that person's vulnerable internal organs, the liver, and this wouldn't be optimal protection in a crash. Another one of our volunteers wrapped the shoulder belt around the armrest. And again, this isn't going to, she's getting not terrible fit, but it's not going to perform. This isn't a strong anchor point. It's not going to perform as needed in a crash. So independence is really important, and these people are doing the best that they can. But we need better solutions that are easier to use so that they can achieve proper use of and good protection from the seatbelt. This graphic over here shows in a study of about 66 or 70 field incidents where people in wheelchairs were injured or experienced a crash event and maybe weren't injured. We noted their seatbelt use status. And if you think of people who are seated in conventional vehicle seating, we see seatbelt use rates of over 80% almost everywhere, and in most states over 90%. And here we're seeing if each section of this pie designates a different seatbelt usage mode. We have 35% of these people in the field who are using no occupant restraint whatsoever, no occupant protection system. We have a few using airbag only, which airbags are supposed to supplement the seatbelt. And so this isn't alarming. The good categories here are lap and shoulder belt, 30% there, and airbag plus lap and shoulder belt, 80%. So we'd say, you know, less than 40% of the people that we're seeing in the field in these dangerous situations are able to use the lap and shoulder belt to protect themselves. There's a large percentage of people who are either under restrained or not restrained at all. And then the last slide about why the emphasis on wheelchair anchored lap belts is that there's a lot of confusion about between belts that are on wheelchairs that are only meant to provide postural support and those that are meant to provide crash protection. So in some ways it's understandable. Like you can see some of this hardware looks a lot like a Crashworthy seatbelt. These are components that look like some things that I see in child safety seats. But this belt was only meant for postural support and was never meant to protect you in a crash. And people are assuming that that can provide protection and not using the Crashworthy seatbelt. So again, having a customized wheelchair anchored seatbelt could reduce this confusion as well. Still on WC19, I wanted to show you, we use this crash test to determine the strength of the wheelchair, the securement points, the belt restraints. We were looking to make sure that the seat is supportive of the occupant, we don't want to see downward collapse or seat back over recline. We want to make sure that all the pieces and parts are staying together and not flying around. Here's an example of some good performing power wheelchair. This is a power wheelchair. See the occupant. It's a significant crash, but the wheelchair is staying in place and the occupant is staying in the seat. Here's an example of a folding stroller type wheelchair. And then just to give a little more detail, we want to, for WC19, we want to make sure that anything that's detaching from the wheelchair is either very light or soft and not rigid. So anything that detaches has to be less than 150 grams. That's about the weight of a bar of soap. You can see this piece came off one of the wheelchairs. It's almost a kilogram, so it's about 2.2 pounds. You wouldn't want this flying around the occupant area, hitting other occupants, hitting the occupant in the wheelchair. There's also a requirement in WC19 that we can't have any sharp edges that are either near occupants or near belts. Seatbelts are made out of this webbing, which is really strong. It's as strong as steel, but if it gets cut, the strength rapidly reduces. So we want to make sure that everything that's going to come in contact with either an occupant or the belt system is nice and smooth and not going to cause a problem for the wheelchair user or for anyone else. I mentioned before, and hopefully you're seeing a theme, that there's just huge issues with getting good use of the seatbelt. So one of the requirements for WC19, since most people don't choose a wheelchair anchored belt and they're using a seatbelt that is anchored to the vehicle, we rate how easy it is to use this type of belt. So how narrow is this gap that I need to thread the belt through? Can I actually insert the belt into a slot? That's easier than having to actually thread an end through an opening, a closed aperture. And then in addition to the ease of putting it on, we rate the actual resulting belt fit. So, is the belt low, touching the top of the thighs, crossing from shoulder to hip across the sternum? And in WC19, we give each of these a rating, and in order to comply with the standard, the wheelchair has to achieve at least an acceptable in each for both ease and fit. The other thing I wanted to mention, just that both WC18 and 19 contain specifications for the universal docking interface geometry. What this is a definition of an interface shape, and it's located in a rough location. It's located on the back of the chair, and there are sort of diameters and vertical requirements for this shape that attaches to the structure of the wheelchair. and can be used to secure it. There was a lot of research done on trying to figure out a location that would work on a wide range of wheelchairs. This is also compatible with electric vehicles where you can't anchor to the floor. This is sort of, you could envision like a flip up seat that has a UDIG interface where you can secure your wheelchair. This has been around for a long time, has developed, an initial version was developed at Oregon State, and then it was advanced significantly by work done in Pittsburgh. And it hadn't really achieved any practical use. We didn't have wheelchairs or WTORS systems that were using this geometry. However, with the promise of automated, autonomous and driverless vehicles, where we would like to see autonomous vehicles show up at a wheelchair user's house and them to be able to secure themselves without a third party to attach straps, or this is seeing revived interest. So I wanted to make everyone aware that this is part of our standards, even though it isn't seeing wide use. All right, so we went through 2 of our standards, now we're on the 3rd one, WC20. So this standard recognizes that not all wheelchairs come from one manufacturer. And so many wheelchairs are, a prescriber might match a specialized seating from one manufacturer with a frame from a second manufacturer, and then combine them to make a complete wheelchair. For a while, people were testing every combination. So, you know, I make seating and I know it goes mostly on these 6 frames. I'm going to test all of those combinations, which is costly and wasteful and things like that. So there's a better way to do it. So WC20 allows specialized seating to be tested on a surrogate frame in a worst case way to assess its suitability. And then, so what does this look like? So the intent is that a seating system that meets WC20 can be paired with a base frame that meets WC19 to create a crashworthy wheelchair. The base frame that we're using, the surrogate base, is made out of steel, and it comes in many different widths. We adjust the width from 12 inches to 22 inches by reconfiguring some of these internal center crossbar parts. The surrogate wheelchair frame has some deformable elements because we want to emulate or simulate typical deformations in the wheelchairs that we validated it against. So there's deformable caster elements here that bend, and deformable elements at the base of the canes that bend, and we replace those before each test. And it creates a more realistic response, but we want this sort of worst case crash loading to make sure that whatever frame you put it on, the seating will perform well. So once we paired up the commercial seating with the surrogate frame, we basically run a WC19 test, and we look at the wheelchair excursions, the dummy excursions. We look at the integrity of the seating system. Do we have cracking? Does the hardware that's attaching the seating to the frame, which we consider part of the seating system, does it stay attached at all the different securement points? Does the seating system support the occupant appropriately? Does it keep them in a upright position? Does it prevent downward collapse related to that? And then again, looking for no projectiles and no sharp edges. And then finally, the 4th section of volume 4, RESNA volume 4, is WC10. And as I mentioned before, this is kind of a different breed because we're talking about a different crash environment. So WC10 is specifically intended for application in large accessible transit vehicles. Think city bus, think rapid transit cars. And this environment allows a wider range of solutions because it's very unlikely to see a high severity crash. I want to show you this graph here where it's million miles of vehicle travel versus the average incidence for a crash, and they're categorized by less than 5 miles an hour, less than 8 miles an hour, less than 10 miles an hour, and less than 20 miles an hour. So if you see this, the transit bus that's in red, on average, will travel 455 million miles before it sees a 20 mile an hour crash event. In comparison, most of these yellow bars are so small you can't even see them, but for the over 20-mile-per-hour category, the passenger vehicle, meaning the sedan, the minivan, will travel 7.2 million miles. So there's a factor of 64 between those two things. So this large accessible transit vehicle is just much less likely to get in a high severity crash. Many times, but reflecting this, passengers are often allowed to stand during travel, and there's pressure for on-time service. And it's the best situation is that people in wheelchairs can be fully independent, you know, getting on, boarding and alighting the vehicle, and riding in the vehicle. And the 4-point strap type system isn't a fully independent type system. So the idea, and I'm sure you've seen these, is that there's a rear facing station, and that usually has a backrest, and it has like a network of grab handles that you can stabilize yourself with. And so this specific thing, the rear facing wheelchair passenger station, is what WC10 is concerned with. So it sets performance criteria for these, and because we know that the likelihood of crash is so low, it doesn't have to involve a crash test like we have in the other 3 standards. Here's an image of some of the spatial requirements. So there was a lot of work done looking, this is a side view of the wheelchair station, and this is a front view. So you're looking straight at that back support. So you want the back support to be wide enough and tall enough so that it provides protection for the person in the wheelchair, but it needs to be narrow enough and short enough so that it can get right up against the seat back with as many chairs as possible. The position of the hand controls is also specified, hand grab handles, and then things like stop request controls. Those locations are also covered by WC10. And then I mentioned that we aren't expecting to see any high severity crashes, but we are expecting to see emergency braking, rapid turning, emergency vehicle maneuvers. And so to address this, WC10 has these quasi-static pulls in various directions. So you pull forward, rearward, and to both sides, and it allows you to assess the containment of the wheelchair and occupant and the lateral stability, because sort of tip overs and falling out of the wheelchair are things that we see often in this environment. Before I wrap it up and we take some questions, I just wanted to alert people to different resources. So there's the Ride Safe brochure. This is a hard copy and a PDF type brochure that outlines best practice for wheelchair transportation safety and can be really helpful in communicating to consumers what they should be asking for and advocating for safe travel. And this comes in Spanish, French, and English. We also host a wheelchair transportation safety website, and it has a not so friendly URL address here because of stupid reasons at the University of Michigan. But some of the cool things you would find there is basic information about the wheelchair standards. There's a bunch of crash test videos that are downloadable that demonstrate the importance of best practice by looking at the outcomes of different sorts of misuse. There's lists of technical publications and consumer publications. We have frequently asked questions with answers. And the thing that most people come to the website for is this updated list of products that comply with the WTS standards. So we have lists of, I think it's nearly 200 wheelchairs that comply with WC19, and their manufacturers have allowed us to add their wheelchair makes and models to this list. So it's a way of, if you're looking for a wheelchair that complies, it's a way of identifying that hardware. This is also an excellent document developed by the team at Pittsburgh that gives you guidelines for how secondary postural support devices should be considered when traveling in motor vehicles. So things like head supports, butterfly harnesses, all different categories of secondary postural supports are addressed in this document, and gives some tips and things to consider for safe travel. This is my contact info and Nichole's contact info. You can use this as a resource if you have questions. And then I wanted to make sure to remind everybody that RESNA is happening July 13th through 15th this summer. It's going to be virtual. So that's all the material I prepared. I wanted to make sure we left room for questions. I think we have 15 minutes. Let's see. Maybe I'll stop sharing and we can look at the chat and see. Okay, so are the slides available for this presentation? I'm going to upload a version of them onto the website. It'll happen tomorrow. Is a head support mandated for clients over 50 pounds? So I'm assuming this means a wheelchair. Is a wheelchair for an occupant that weighs over 50 pounds required to have a head support? It is required to meet a rearward head excursion. That's much easier to meet if you have a head support, but it's not required to have a head support. And that's because we don't see consistent performance in terms of crash safety for head supports. So a lot of people think, oh, there's a head restraint on my vehicle seat that helps protect me in a rear impact crash. And wouldn't the head support on my wheelchair do exactly the same thing? Some of them do, and some of them don't. Some of them come off and become projectiles. Some of them don't stay aligned with the head enough to provide support. Also, there's a lot of people who want to travel while seated in their wheelchair where a head support would interfere with their activities of daily living. So no, it's not required, a design requirement to have a head support on a wheelchair, as long as the intended occupant's over 50 pounds. Can these standards apply to air travel? So it's interesting. I just served on a committee for the National Academy of Sciences that investigated the feasibility of staying seated in your own wheelchair on aircraft. And long story short was that the committee found that it is feasible to do that. And we don't see any airlines doing this already, but this report from the National Academies is kind of a first step in that direction. And there's several advantages there, but the report investigates, door openings and pathways to different seating areas, and the feasibility of wheelchairs. There's different crash testing that's done on aircraft seats. So not only is there a frontal crash test, but there's also a emergency landing where there's more of a vertical component to the crash test. And so yes, I'm trying to explore options of expanding these to those crash conditions, but right now they aren't included. Will RESNA ever look at unoccupied wheelchair transport? So in general, you can use the same tie downs to secure an unoccupied wheelchair. We have looked at, and we have people that voluntarily test to sort of in the spirit of WC19 with unoccupied wheelchairs. There are some concerns and about confusion. So if there are securement points for unoccupied, how do we distinguish from the ones that are for occupied? We wouldn't want people confusing something that's only meant to be used unoccupied for occupied. So there's some labeling issues. It has been voiced to us, but it isn't included yet. Can I put my contact up again? Sure, I can do that. Let's see here. There we go. And sadly, wait, now I can't get back to the comment. I should be able to do the chat. Okay. Do the standards allow or not allow for transportation of adults in a standard off-the-shelf folding wheelchair with a client in the chair? So standard off-the-shelf folding wheelchairs certainly can meet WC19. They would need to be designed and tested for that purpose. I think there's a lot of inexpensive wheelchairs that are meant maybe just for like transport around a hospital that that have sort of a standard design, and many of them are not crash tested. Our county agency highly discourages it for our own agency private providers in our area, even with tents and safety belts. So there, the fact that a wheelchair can fold does not mean that's unsafe, necessarily unsafe for use as a seat in a motor vehicle. We see lots of folding wheelchairs that do fine relative to WC19. WC19 really focuses on the performance of the wheelchair and tries not to add too many design requirements. Has there ever been any progress on the harmonized ISO ANSI standards for lap belts, symbol for lap belts, which are intended? So let's see if I can get back to it. So in the, or maybe I have to unshare or no. We have implemented that symbol, which is that round target. I'll try to move back to it if I can. And if the new version of WC 19 and of 7176 part 19 passes this month, it also has a symbol very similar to it with it's the same symbol, only it has a designation for ISO in one of the quadrants. We are working on, we are talking right now about implementing it in some of the other ISO standards. It's not going that great, but it would be in part 19, a similar symbol. So that hopefully just to help people identify which belts can be used as seat belts, which belts can take that high loading. All right, I think that I have answered all the questions in the chat. If I missed your question, oh wait, maybe there's a new one. Are captain style seat consumer power chairs safe for transport? So I think what you're referring to is it's a seat of the wheelchair looks a lot like a seat in a boat or a captain style seat in a motor vehicle, and it's usually supported by a single post that comes up the middle. These can be some of them, but if you take just a wide range of them, there are some that comply with WC19 that pass the crash test, and that single post braking would violate the standard. It would not comply. So yes, there are some that pass WC19. There's probably more that do not pass WC19. I think that there was a while back, may even be like 8 years ago now, the VA specified a product Tinder that included a lot of wheelchairs like that, and we saw a big wave of them get crash tested in our lab, I'm sure in other labs too. But I don't know what percentage of the big fleet of wheelchairs that style that comprises. Is there a symbol here? I'm gonna go, hopefully I can see if I can get this to go back. There is a symbol. I think it's going to get stuck on the videos, but there it was. Oops. So this is the symbol. It is one of our crash test targets, and it includes a symbol for wheelchair user and a vehicle. And this symbol, since 2017, is required. If you comply with WC19, this is required to be on your wheelchair, on your hardware. So yes, there is a symbol that is put on wheelchairs that are crash tested. All right, well, questions are slowing down. Let's see, any recommendations for securing power wheelchairs that have more sideways movement of seat during transportation due to elevation systems? Oh, like so might have a lift component or a suspension component. So in general, when we see systems like that meet WC19, those are usually the situations where you have either the securement points are up on the seating so that you're stabilizing the part of the wheelchair that's closest to the occupant, or several of them, because the seating is usually heavy, fall into that category where there are 4 securement points on the back of the chair, 2 on the seating and 2 on the base. And that does produce good performance. So I think that the key to achieving good performance there really is making sure that you're controlling the seat as well as the base. So I just wanted to thank everybody that was here and everybody who stayed. I think that there might be a code that Riley's going to give out for continuing education credits. And I will thank you. Thanks for coming to my presentation. And it was, I always learn a ton from the comments and the questions that you guys give me. So it's great. Wonderful. Thank you.
Thank you, everyone. And thank you so much, Miriam. Your code for today's session, which will also be put in the chat, is GT0HOS. Once again, that's GT0HOS. Thank you so much, everyone. And again, thank you to Miriam for a great presentation today.
Thanks, everyone. Stay safe, warm.